Get about 20 minutes to do the presentation, and then give about 10 minutes for us to come up and really take a look at the robot. Good luck.
My name is Daisy Fernandez, and I'm electrical.
My name is Joshua Vidya, and I'm a builder on the team.
My name is Isabel Martinez, and I'm electrical.
My name is Jesus Raz, and I'm a builder.
My name is Pedro Crow, and I'm a programmer.
My name is Kenneth Reese, I'm a builder.
My name is Ulises Ross, and I'm a builder.
My name is Carlos Rubio, and I'm a
Hello, my name is Dylan Day, and I'm the lead designer.
My name is John Rangel, I'm the head programmer.
My name is Desiree Sanders, I'm head of public affairs.
My name is Bianca Rodriguez, and I'm head of the education team.
My name is Martin Carranza. I am the chief of construction and the captain of Falcon Awards AAB team.
So, we come from Croahin High School in Phoenix, Arizona. The majority of the students there are Hispanic, and many of them qualify for the federally reduced lunch program. We've been doing land and underwater robots for about 10 years now, but most of those have been teleoperated, and we've actually won some competitions and stuff. We receive no funding from our school, and all our funding we have to work for. We have to look for our own sponsors and donors. Here's a list of them, and draw on our shirts as well. See that. 90% of the students who go through the program actually graduate high school and continue their education, go to college, and pursue a degree.
So our team has a mission, and that mission is to promote STEM within our team and our community. And we do this by hosting different STEM events. Some of the events that we host are, one of them is FLO. FLO stands for First Lego League. And we have been doing this for around 6 years now. And it's basically where kids come together, middle schoolers and elementary students come together. They build robots out of Legos, and they compete at our school. And along with FLO, some of our members of our team go out to their schools and they mentor them. So they help them and show them what to do. Another event that we host is the Arizona Science Tech Festival. The Arizona Science Tech Festival is an organization, and they basically said, we need help, so can you guys help us? And we accepted, and we hosted a day of robotics and engineering. So we basically brought robotics, solar cookers, solar cars like Teslas, Chevy Bolts to our public so they can see. Another event that we hosted within our campus is a science fair. We haven't had a science fair since 20 years, and this is the first year that we've had it. It was a good success. A lot of students created science fair projects, and it was good. Another event that we do is NERC. NERC is National Underwater Robotics Challenge. It is a competition we host. It's similar to AUVSI. So instead, it's teleoperated robots. There's 3 different categories. One is NERC Light, NERC, and NERC Auto. NERC Light is for the younger kids, middle school, elementary. NERC is for high schools, and NERC Auto is a new category based and similar to RoboSub. It's for college students and high school students, whoever wants to take the challenge, basically. And that's what we do, and that's what we try to succeed in.
So some of the things we actually learned from RoboSub last year was that we needed a new way to store all our electronics. Because last year we had a big rectilinear hull, and it took up a lot of space, displaced a lot of water, and caused us to be pretty much near the weight limit. So what we came up with was a simplified hull with simplified sealing. So it's all aluminum, so it conducts heat better, so that it keeps all our electronics cool. And it also displaces less water so that we can be more under the weight limit and get bonus points, as well as having a easier to seal the hole method so that it's quicker to take all the electronics out and put it all the way back in. Another thing we have is tether for both teleop and programming. We wanted to have that because we wanted to control the robot remotely from the land, because last year we only had a monitor on the robot itself. Another thing, we have a tether for power, so we can run on off-board batteries instead of using the batteries inside the robot itself. So instead of having to, let's say, take the robot out over and over again every 30 minutes to change the batteries, we can just take the batteries out on board and replace them. And so we can go hours of testing non-stop.
In our AUV design, we feature a drive system called Vector Drive. We use this for its maneuverability, and we also want to design our AUV so it's very compact and dense, so we can keep with a smaller AUV rather than a large one. To remove all our electronic components at once with ease, we have something called the electronic lattice structure. So this is the electronic lattice structure. This is what we use to hold our electronics components inside the AUV hole. To keep our robots, torpedo shooters and marker droppers simple, we use solenoids for the marker droppers and sprinkler valves for the torpedo shooters. Just any ordinary items you could buy at a local shop. So if anything were to break, it would be easy to replace. And we have a power tether. The power tether is used so we can code and practice on the AUV for a longer period in time, rather than using the batteries itself. And we also have a fiber optics cable. This cable serves for a faster connection rather than a standard Ethernet cable. And we also have, finally, we have the external battery pods. We keep these batteries separate from our electronic system, so if anything were to ever go wrong with the batteries, our electronic system would be unharmed in either way. And we have these spring-loaded latches on our AUV holes for a quicker sealing method.
So instead of trying to do everything in 1 year, we decided to divide everything into a strategic 3-year plan. So the first year, we're going to start simple and build a robust robot platform so that we can program without having to worry about any mechanical or electrical failures at all. That way, if there's any problem, you know it's just the code and you don't have to worry about any of your electronics failing. Another thing is that we wanted to basically develop a simple base code so that we can add on it in later years. For this year as well, we also want to do very simple tasks such as going through the gate, aligning on a marker, hitting a couple buoys, and then using Google Earth coordinates to pretty much dead record for the rest of the course. For our second year, we wanted to improve components even further and do more complicated tasks such as dropping markers in the bins or shooting torpedoes or maybe even doing the grips. And then for our third year, we really want to bring out the big guns. Basically, we want a DBL and a hydrophone system so we can triangulate sound, do all the mission tasks, and hopefully win the event.
So our AUV hull is made of aluminum, as you can see here. We tried to go with aluminum because it is easy to machine, it's light, and it's a good heat conductor. Since in Arizona it's really hot, and we like to keep it everything cool. We also have last year we learned this from Team Sonia. So they had spring-loaded latches, which are extremely easy to use, and they're really good because they allow you to access your electronics whenever you need to. And we also have 2 portholes, one front and one in the bottom. They're for our cameras. So these portholes are made waterproof with a standard O-ring seal, and they have these stainless steel fasteners all around them to keep the O-ring pressure and make them hard. So our AUV frame is also made out of aluminum. It consists of 3 main parts, our 2 A-frames and our main frame, which are all cut using water jetting. They are all put together using stainless steel fasteners and angle aluminum. So when we got our frame up, it was also kind of heavy, so we decided to just put it on the mill and do a bunch of hole patterns to make it lighter. So that dropped our weight a couple pounds. Also, our hull and frame have this new anodization that was just recently invented and patented. So we have a friend back in Arizona. His name is Walt Anden, and he just recently invented this new process. So this new anodization process makes standard anodization 50 times stronger, and it makes it more resistant.
So as I mentioned earlier, this is our electronics ladder structure. This allows us to place square or rectilinear devices into a curvilinear hole, and provided by PADT, Phoenix Analysis and Design Technologies. This material is made out of Duraform, PA and GF thermoplastic. We use this type of material because it is non-conductive, transparent, and very light. We feared this kind of method might be a little weak, So we designed channels throughout the system that we can place steel rods in there to enforce the whole string. So you guys can pass this around as well.